Hello my dear students, let us take some more examples on shear stresses in the beams. Let us take this example. A simply supported beam of 200 mm wide and 300 mm deep supports an UDL of intensity W Newton per meter over a span of 4 meter. Calculate the safe intensity of load that the beam can carry if the permissible stresses in bending and shear are 56 Newton per millimeter square and 4 Newton per millimeter square. So what is given here? Breadth is given 200 mm and depth is 300 mm. W you have to calculate and length is equal to 4 meter or 4 into 10 raised to 3 millimeter and sigma B bending stress, that is 56 Newton per millimeter square, and tau, that is 4 Newton per millimeter square. So you have to calculate W. So how you can calculate? What you have to do here? Here both bending and shear stress values are given. So you have to calculate W by using bending equation as well as shear stress equation. Once if you get W, you have to see which is the smaller value, that is the safe intensity of load. So let us first find the W using bending equation. We know for a simply supported beam, when it is a UDL, maximum bending moment is given by M is equal to WL square by 8. This you have studied in shear force and bending moment in the beams. That chapter you have studied what are the different bending moment for the different condition. When it is a point load, what is maximum bending moment, what is maximum shear force. When it is subjected to UDL, what is maximum bending moment and what is maximum shear force. When the beam is cantilever, if it is load is at the free end, what is maximum bending moment and shear force, like that. So different conditions you have studied. So in one of the condition is here, that is UDL, bending simply supported beam with the UDL. That is formula is M is calculated by using the formula WL square divided by 8. So calculate first what is W here. W we have to calculate into L square. L square is 4 into 10 raised to 3 square divided by 8. So you get M is equal to 2W into 10 raised to 6 Newton millimeter, because this is moment. So here whatever this is given in Newton, so we can write it is in Newton, and this is the millimeter, so millimeter. Now we have the formula maximum bending stress, that is equal to M divided by I is equal to sigma divided by Y. Now we have to see this in this equation. We know M, that is 2W into 10 raised to 6. I we can calculate, that is this is a rectangular section, so that is BD cube divided by 12, and sigma that is given 56, and Y we can calculate, that is D by 2. So once if you calculate that, substitute all the values in this equation, you get what is W. So let us first find I, that is BD cube divided by 12. So what is so if you substitute, B is equal to, what is the B value? B is equal to 200 and D is equal to 300 cube divided by 12, you get 45 into 10 raised to 7 millimeter raised to 4. Then you have to calculate what is Y. Y is equal to D divided by 2. The depth is 300 divided by 2, that is equal to 150. Now you use this formula M divided by I is equal to sigma divided by Y. So M is equal to this calculated value 2W into 10 raised to 6. Substitute that, divided by I is 45 into 10 raised to 7 is equal to sigma is equal to given 56 divided by Y is equal to 150. So only one unknown, W, you get 84. This all terms are in Newton, that's why I have written Newton, and this is per millimeter because this is UDL. So Newton per meter or kilonewton per meter or Newton per millimeter or kilonewton per meter, we have to write, that is intensity. That's why I have written 84 Newton per millimeter. Now this W is calculated by using the bending stress equation. Now let us calculate W by using shear stress equation. We know maximum shear stress for the rectangular section, tau maximum is equal to 1.5 times of tau average. Okay, so tau maximum is equal to what is tau average? That is F divided by area. Area of the rectangular section is BD. So if you substitute area is equal to BD, so what is tau maximum? That is equal to 1.5 into F divided by BD. Now for the simply supported beam, when it is subjected to UDL, shear force is given by WL divided by 2. Maximum shear force is equal to WL divided by 2. So substitute here, what is W? W we don't know, we have to calculate. L is 4 into 10 raised to 3 divided by 2. So you get 2 into 10 raised to 3 W. Now this is F. Now let us find what is W by using this equation. Tau maximum is equal to 1.5 into this is F is 2 into 10 raised to 3 W divided by BD. BD is 200 into 300. So you get W is equal to 80 Newton per millimeter. This is also again intensity. That's why you have to write 80 Newton per millimeter. Now what is the safe intensity of load? That is smaller among the two values. So by using bending stress equation, you get intensity is equal to 84 Newton per millimeter. By using shear stress equation, you get W is equal to 80 Newton per millimeter. So smaller among the two value, that is equal to 80 Newton per millimeter. Therefore, safe intensity of load is equal to 80 Newton per millimeter or 80 kilonewton per meter. So in this way, you can calculate what is the safe load. Let us take one more example, similar type. Okay, this a simply supported beam of span 1.3 meter having a cross section of 150 mm wide and 250 mm deep, carries a point load of W at the center. Calculate the safe load that the beam can carry if the permissible stresses in bending and shear are 7 Newton per millimeter square and 1 Newton per millimeter square. Same type, only the loading condition is different here. In this case, simply supported and beam is simply supported and the load is point load which is acting at the center. So what is given here? B is given, that is 150 mm and D is equal to 250 mm, L is equal to 1.3 meter and sigma B is equal to 7 Newton per millimeter square and tau is 1 Newton per millimeter square. So let us calculate first load using the bending equation. So for that you have to calculate maximum bending moment. In this case, it is a simply supported beam with the point load. So maximum bending moment is equal to WL divided by 4. So substitute what is say L. L is 1.3 into 10 raised to 3 divided by 4. You get 325 W Newton, because this is only load, point load. So this is given by Newton. Now we have bending stress equation, that is M divided by I is equal to sigma divided by Y. Substitute all the values. Before that you calculate what is I, what is Y. So how you can calculate I? I is equal to BD cube divided by 12. You get this answer. Y is equal to D by 2, that is 250 divided by 2, 125. Then M divided by I is equal to sigma divided by Y. M is equal to that is calculated value here in this you got M is equal to 325 W. So substitute 325 W divided by I is 195312500 is equal to, stress is given 7 divided by Y is 250 divided by 2, that is 125. So you get W is equal to 33,653.85 Newton. This is using bending stress equation. Let us calculate W using maximum shear stress equation. Same way, maximum shear stress is equal to 1.5 times of tau average. So tau maximum is equal to, you can write tau average is equal to F divided by BD. So if you write that, you can substitute here what is shear force. F is equal to, in this case this is simply supported with the point load at the center. So shear force is given by W divided by 2. So that is W divided by 2 is 0.5 W. Now substitute values in the equation. So tau maximum, that is 1, is equal to 1.5 into 0.5 W divided by 150 B, and D is 250. So you get W is equal to 5000 Newton. Okay, sorry, 50,000 Newton. So what is permissible or safe intensity of the load? It is smaller among the two values. So here smaller value is 33,653.85 Newton, or 653 kilo Newton. Okay, this is just 33.65 is enough. Okay, is kilo Newton. This is the answer. So this is very important. Usually this type of problems comes in the exams also. Main thing, you have to know how to apply the formula. Like when it is simply supported beam, you should know what is maximum bending moment, what is shear force. And if it is a simply supported beam with the UDL, you should know and what is maximum bending moment, what is maximum shear force. Similarly, the cantilever, there are two cases, load at the free end and UDL. So these four conditions you have to remember, and then only you can use that formula, and you can find what is W. I hope all of you understood. If you have any difficulties, we can discuss in the class. Thank you.